Going on now to section 7, another little bit on word problems. I like this table. What they're asking us to do is, if we have this many pennies, how much would it be worth in terms of dollars? Well, each penny is 1/100th of a dollar, so 0.01 times x. Now, dimes are worth 10 cents, so 0.10. Quarters are worth 25 cents, so 0.25. Now, $5 bills would be 5 times this amount. This would stand for the value of, if you had this many bills, that would give you a dollar value. This is for $20 bills. This is for $30 bills. By the way, I looked at a test recently and they had this on it, or some of it. This can get complicated fast, so let's see what we have here. We have a train that's going 120 miles an hour, another train that's going 80. They're wondering how far will they be from their origin when they meet. Now, we don't know this time, but we know the slower train had 1 hour more. So it would be this time plus 1 hour more. So there's your equation where we have distance equals rate times time. We have, in a sense, distance equals distance. This is rate, this is time. This is rate, this is time. Now, when we solve this, we're going to get time as a certain amount. But they don't want time. They want distance. So once you find the time, that is, you solve for t here, you multiply that t by 120, and that gives you 240 miles. Now, example 8 is the very same. It's a car traveling at 65 miles an hour, another car traveling at 50 miles per hour, and they're wondering when will they pass or catch up. This slower one had a 2-hour head start. So this is its time, and we have then rate times time equals rate times time, because distance equals each other. Now here they want to know how long. So when we solve for t, it comes out 6 2/3 hours. Now, I noticed when someone was putting this in their test the other day, they would put like 6.666 or something, and it was 2/3, but they didn't accept the inaccurate or the approximate that. They wanted a mixed number. So look very carefully how you put in the answers. You did all of this. And if you're off just by a little bit, be sure to call on one of the instructors so we can maybe give you partial credit. Now, in example 9, kind of a little tricky, and it did take me a little while working on it too, but here's the summary. So they're driving 55 miles an hour one way, 45 miles back because of icy conditions. Total travel time is this. Now, find the distance one way. Well, we know the distance from and there is the same as when they return. So distance equals distance again. So we're going to have 55 times t, which is that portion of this time that they're going to use. Well, what's left? Well, we go to our box here, where this is the total time. T is part of it. And then the marvel of algebra is this is the other part. So we didn't know how to divide this up or what portion. The algebra does it for you. So our equation is 55t equals that. I multiply 40 times this, I get 190. 40 times this is a negative 40t. I transpose that, and it adds up to 95t equals this. My time is 2 hours. Yes, but they want distance. Well, I go 2 times 55 here, 110 miles is the one-way distance. Okay? Okay, here we're going to use our technique of money. So here's a person, there are 12 times as many dimes as quarters. So we don't know how many quarters. So let's say Q equals the number of quarters. Now, how many dimes did you have? Well, 12 times Q. So this is the 12Q, the number of dimes. And the value is this much. So what is a quarter worth? Well, 25 cents times the number of quarters. 10 cents times the number of dimes. And that total is this. Now what I would do here too is get rid of the decimals. I'd make that a dot there, a dot there, and just move this over here too. Okay, and when you solve it, you get there are 15 quarters. Multiply 15 by 12, and that gives you 180 dimes for number 10. Now here's someone very lucky, received $30,000 in inheritance. He will invest part of it at 6%, the other part at 9%, and he gets this much interest in 1 year. How much did he invest in each of those? Well, here's the case where we're using our box again. This is the 30,000. We're going to say N is the amount at 6%, and 30,000 minus N is the amount at 9%. Okay, looks like a funny 9 there. Okay, so anyway, this is 9%. There we go. And that's the little percent sign. So our basic formula is interest equals principal times the rate times the time. Well, since it's 1 year, we can disregard the t. So there's our first part, 6% of some part of that 30,000. And then 9% at the other part. Again, we don't know this part. And you might say, how does the algebra figure it out? That's the marvel of it. So what strategy might you use? Well, I would get rid of my decimals. Now over here, by the way, in order to get rid of them, I'm going to have to add 2 places. Okay, and I'll solve this for you. Once you get it set up, it's not too hard, but remember, hopefully this is going to serve as a model of how to do these. And if you look at your textbook, they work out some, and in the previous lesson I worked out some as well. So notice what we have. We added 2 zeros there. This was that. Multiply, distribute, got this. Now I'm going to combine like terms. I get a negative 3n. I'm going to subtract this from both sides. So I end up this being negative here. And when I divide both sides by a negative 3, I end up with n is 20,000. So what would be the 9% investment at 10,000? Now I always wonder about this. Why would someone ever choose the lower rate? Put the whole bit at 30,000, but again, then we wouldn't have this problem. All right, let's go on. Now we did some of these in the last section. What number is this percent? So the number is this percent of that. This 650 is what percent of that? So we're just going to divide both sides by 130. Now when you do that, you get 5, but it's not 5%. Remember the decimals there, you have to add 2 zeros, and then the percent sign. 5 is actually 500%. And when you do this one, you get 1.5, which is 150%. Again, move it over 2 decimal places, add a 0, and then here you add your percent sign. But we're moving right along. Here we have an auditorium that holds 500. Child tickets are at $25. Adult tickets are at $50. And this is your total income from the sale of all the seats. How many of each did you have there? Well, again, there were 500 seats available. A part of them, we're going to say N, were the children. Then 500 minus N were the adults. So 25 times the number of children attending, 50 times the adults, which was the rest of the auditorium, and there's the total. So again, you do the algebra. You don't have to do any decimal points here. And they were eventually, these were 270 children, and this was 230 adults. All right, going on to the next part. Here we have people that are this many miles apart on a trail, and they're walking toward each other. So this one's starting there, and they're going to meet. Now, one person is walking twice as fast as the other. So that person's rate is 2r. This person's rate is only r. And the time that it took was 1 hour and a half. So again, it's rate times time. So there's the fast rate times that particular time, the slow rate times that time, and then the total distance that they're walking altogether is 9 miles. So how many, what are they asking here? Find the rate of each person. So again, you multiply this. This is going to be 3r plus 1.5r equals 9. This then becomes 4.5r equals 9. R is 2. So the slow rate is 2 hours, and the fast rate, just double it, is 4 hours. Okay. Well, I looked at number 7 for a while here, and it seems to be missing something. I don't see any time that they spent. So here he spent part of his time 60 miles an hour, part of the time 70, but it doesn't say how many. I think they left that sentence out. Anyway, they gave the answer as these over here, but I have no idea how to figure that one out. Okay, number 18 I got pretty well. It's similar to one we did already. We have twice as many 20s as 10s. So N will be our 10s, and they're worth $10 each. And 2 N's will be our number of 20s, and that will be $20 each. And you solve that, you'll get the number of 10s, and then you subtract that, and you will find out how many of each kind you had. All right, in number 10 here, it's a discount example where the prices were 400. They went down to 260. So when you subtracted that, you got a difference of 140. That's one of the answers. That's the amount of discount. And then when you place the 140 over the original price, that comes out to be 35%. And for this last one, 3% salt, and you needed 20 altogether. So we're going to take that 20. I didn't make my little box, but I think it might be helpful. This box stands for 20. We want to divide that into two parts. So part of it will be n. The other part will be 20 minus n. We've done that a lot in these last few lessons. So this will be your 3%. What's left over is the 8%. And you're looking for an end of 6% of 20. Again, get rid of the decimals, multiply through, n will come out being 8. Then you subtract the 8 from the 20, and you get 12 for your 8%. And that will wrap this up, and we're just over 15 minutes.